So you can see at the top here, 3.5 gets into the derivatives of our 6 trig functions: sine, cosine, tangent, secant, cosecant, and cotangent. As we're working through these, I'm going to give you this graph at the top of the paper. One of the things that's going to happen as we're working our way through these is we're going to encounter this limit where we're going to take the cosine of x minus a 1 and then figure out what is our limit as x goes to a 0. So there's no shortcut for this. We would have to do a little XY chart for all of that. Like I've mentioned before, a graph is the perfect XY chart because it's going to show every point on this graph. So what I'm showing you is the graph of that function. So we're going to use the graph, which in, again, the way is the XY chart, to answer this limit question. So as x approaches 0, which is what I'm asking you to do, as we approach that value from both sides, so as I approach from the left and as I approach from the right, you can see here that our limit is going to end up being a 0. There is a little hole here because the 0 is going to make this function undefined. If we put it into our calculator, your table would confirm that. So there is a hole, but that doesn't prevent us from having a limit of 0. So keep that in mind because we're going to come across that here shortly. So our first thing we're going to do is figure out what is the derivative of sine. So we know our derivative formula. That's what we did last chapter. So this is the instantaneous rate of change formula, derivative formula, however you want to approach it. So what we need is an f of x, which we have, that's here, but we also need the f of x plus h, so that's what we're going to get right here. So underneath that, right, your f of x plus an h, so then that would equal the sine, and then instead of sine of x, it would become the sine of x plus h. Once we have that, we can go ahead, substitute in. So the f of x plus h for this problem is the sine of x plus h, so we can put that in that spot. Then you would have your minus the function. The function in this case is sine of x. All of that gets divided by h. We now have a regular old limit problem where we're going to go through our options of trying to substitute, and we can't. If I try to take the 0 here and plug it in for the h, you're going to get an undefined value. So the next option is simplifying this. So we've now encountered a few where simplifying is not just factoring, it's the same here. So what you're actually going to have to deal with, old idea from last year, we can't distribute a sign. We can't write that as sine of x plus a sine of h. If you remember, there's an identity for the sign of a sum, and that's what we have here. So the sine of x plus h, there is an identity for that. And what we get for that, what that identity is. So if I have the sine of x plus h, you probably used like a's and b's last year. What that is the sine of the first term, the cosine of the second term. So we get sine of x, cosine of h. Then we would add, and we flip that combination around. So now it's the cosine of x and the sine of h. So all of this comes from right here. It's the sine of a sum. If you don't remember that, hopefully that, if you didn't remember it, hopefully that's now familiar to you. You at least can kind of remember having covered that. We would still, though, have after this minus sine of x. And then all of that gets divided by our h. From there, as h goes to 0, what I'm going to have you do is rearrange. So I'm going to put this term first, this term second, and then this term third. So we're going to write this as sine of x, cosine of h. It's our first term, minus the sine of x, and then plus that third term that I mentioned is cosine of x, sine of h. So smaller so it doesn't run into that. Okay, so get all that down. And then again, all of this gets divided by h. So the reason we did that, the reason we put that in the order, if we look at these first two terms now, notice how you have a common factor of sine of x. So the next step, all we're doing is factoring out that sine of x. That would leave us with a cosine of h is the first term, and then a minus 1 is the second term. And then we'd still have cosine of x, sine of h, and then that's all over h. So usually at this point, I would put on the board, make sure we understand that if I have a 6 plus an 8, and I ask you to divide by 2, we could certainly do 14 over 2 to get our 7. But as long as I am dividing by a monomial, I can split this fraction up. So 6 divided by 2 would be 3. 8 divided by 2 is 4. It's still going to give us that same value of 7. So that's what we're going to do over here. I like doing this with numbers because it's easier to see and understand how that's the same. So we're going to do the same thing over here. So here's our plus sign now. So we're going to take the left side of that addition sign. We're going to divide that by h, and then we're going to do plus the cosine of x, the sine of h, and we're going to divide that term by h. Next thing, if I gave you this, 6 times 8 divided by 2, most people would say that's 48 divided by 2, and the answer is 24. That's correct. But we don't necessarily have to multiply these together first and get our 48. We could, if we want, do 6 divided by 2 first, get a 3, and then multiply that by 8. Still gives us 24. So with numbers, easier to see, but that's again what we're going to be doing over here. So the limit as h goes to 0, what I'm going to do is I'm going to leave sine of x alone, and I'm going to multiply. And we're just going to do the cosine of h minus 1. Let me rewrite that. That doesn't look good. So this is the cosine of h minus a 1, and then that all is what we're going to divide by h. Same over here. Leave the cosine of x alone, and we're going to do times the sine of h over h. We're actually ready to answer this question, even though you may not think we are. So we're going to go ahead and say, let's let our h be a 0. So the sine of x would not be impacted. It doesn't have an h term. So that just drops down. You're then going to multiply it by, and then now focus on what this looks like. So this little cosine of h minus a 1 over h, that's what we have at the top of our paper. So if we come back to this here, they're x's instead of h's, but it's the same exact idea. And what we found is that limit is a 0. So as x goes to 0, for this function here, our limit is going to end up being 0. So this whole thing then is going to become smaller and smaller and smaller, and eventually has a value of 0 or limit of 0. Plus cosine of x doesn't get changed because it's the h that's going to 0. And then we are left with an old rule from last chapter that most of us did fine on that test, where you have sine of h over h, we have the h going to 0. So if you remember how we just looked at their coefficients, the 1 and the 1, and then we would divide those, that's what this limit would have to be. It would be a 1. What we're then left with, this obviously cancels, so that's going to be all gone. The only thing we are left with is a simple cosine of x. That's our answer. So what that means we just found is the derivative of sine of x is fantastically the cosine of x. So if I wanted to figure out how, or what's the slope of the sine of x at any x value, I would just figure out the cosine values at that x coordinate, which is interesting, okay? That you'll just want to get memorized. I do on the test typically, so whether this be a file upload or something, I don't know what I'll do exactly, but I do on the test want to see you work through one of these two. The others get a little bit easier, but sine and cosine are the long ones. That's why you see a lot of space for them. But long term, for the most part, except one question on the test, you want to get this memorized. All right, so now the next one. Same thing for cosine. We're going to do cosine of x plus an h. We're going to do the limit as h goes to 0, and then we want our f of x function, f of x plus h, a function, minus our f of x all over h. Like the last one, we can't really do much with that yet, so we have to simplify it. There's also a cosine of a sum identity. That one was the cosine of the first term, the cosine of the second term, minus the sine of the first term and the sine of the second term. We'd still have minus cosine of x, all divided by our h. Similar steps now. We're going to rearrange this a little bit. So what I'm going to do is I'm going to put this first, which it already is. So rewrite that one. Notice how this has a cosine of x. This also has a cosine of x. So I'm going to put that second. So minus cosine of x. The last term then is that sine of x times the sine of h term. All of this gets divided by h. So as h goes to 0. The reason we do that is so that these two terms that have cosine of x, we're going to now factor that out. So that's our common factor. We'd have cosine of h left in the first term, minus a 1 for the second term. And then the third term on the back, we're just copying. Similar little algebra shortcuts now. We're going to take that h and we're going to put it and divide it into this one, and we're going to divide it into that one. So we're going to split this fraction up into two fractions so that just this gets divided by h and then this gets divided by h. Also similar to the previous problem, we're now going to take this product and we're just going to divide one of those two terms by the h. And that one, so let me get rid of the big fraction bar, if it'll let me. There we go. We're just going to divide this guy by h, and then whatever that gives us, we'll multiply by the cosine. And then the same thing over here. We're going to take our h and just divide it into the sine of h. Whatever that gives us, we'd multiply by sine of x. At this step, we once again have this combination, this function that's at the top of the page. As our h goes to 0, what we said is that function, as we get closer to 0, has a limit of 0. So this would have been the cosine of x times a 0. So now that's going to drop out like it did in the first one, like we did in the sine of x, minus sine of x. So this wouldn't get changed by the h, going to 0. And then this, similar to the previous one as well, this has those coefficients of 1. The limit of that is then 1 over 1. So what we are left with then is a negative sine of x. This is our answer. So like I mentioned before, you most likely will have to prove one of those two to me on the test. But other than the test, you just really want to get this memorized. Derivative of cosine is negative sine of x. Those are the two long ones. Those definitely take the most time to go through. The other ones we cheat a little bit. And by cheat, I mean we're not going to use the derivative formula. So we're not going to use this here. We could if we wanted to, but it's going to involve some identities that we are not familiar with. So we're going to cheat a little bit. And here's what I mean by we're going to cheat. I have this one worked out for you. We're going to take tangent, and we're just going to rewrite it as sine over cosine, something that we already know. So what that basically means is the derivative of tangent, since that's a sine over a cosine, the derivative of sine over cosine is the same as the derivative of tangent. So instead of doing the derivative of tangent, we'll do the derivative of this fraction. And the reason we're doing that, you just quizzed on it, it's the quotient rule. So if this is now a quotient, I'm going to take this term, this is my denominator, that's unchanged, so that's why this just reappears. And then we need the derivative of our numerator. So the numerator was sine of x. The derivative of sine of x is this cosine of x. Quotient rule we subtract, so that's where this minus sign comes from. We then leave the numerator alone. The numerator was the sine of x over here. So that's why this remains sine of x. And then we have to take the denominator's derivative. Here's our denominator. The derivative of cosine is this negative sine of x. Then all of that gets divided by your denominator squared. So this is our denominator getting squared. So all we did here, so all this really is the quotient rule with sine over cosine. So you've already tested on the quotient rule. We now know the derivative of sine and cosine from the top of the page, and we're putting those two ideas together. What that then does, if we multiply these together, cosine and cosine multiply together will give you this cosine squared x. A negative sine of x times a negative sine of x will give you a positive sine squared of x. This is the identity that everybody remembers every year. Cosine squared plus sine squared is a 1. So what we ultimately end up with is a 1 divided by that cosine squared. And since 1 divided by cosine is a secant, 1 divided by cosine squared is secant squared. So this is what you got to get memorized for tangents. That's 3 of our 6. Let's move on to the other 3. That's how we're going to approach these next few. So the derivative of cosecant, we don't want to have to set up that derivative rule, the formula. So what we're going to do is rewrite this as 1 over sine of x. So the derivative of cosecant should be the same as the derivative as 1 over sine. We now have a quotient rule. So I'm going to do the derivative of my denominator. I'm sorry, the denominator unchanged initially. Then we do the derivative of the numerator. So here's the 1. The derivative of a 1 is a 0. Quotient rule, we subtract. We then leave the numerator alone, so that's a 1. And take the derivative of our denominator. The denominator is the sine of x that we learned on the front page. The derivative of sine of x is cosine x. And then quotient rule, we always square our denominator. What we should see, that drops. You will then get a negative cosine of x over sine of x squared. That's sort of our answer. It's not necessarily wrong, but that's not the simplified version that you're going to hear people say is the derivative of cosecant. So to get to the simplified version, what I'm going to have you do is I'm going to have you do this. Do a negative 1 over sine of x multiplied by that cosine of x over the other sine of x. So hopefully we can see when we do that, so go ahead and write that, that if we were to multiply these together to simplify this, it would give us this negative cosine of x times sine squared. They're equivalent, just written a little bit differently. Because then that's going to allow us to write this in the way that we want to recognize the derivative of cosecant. This here is a negative cosecant. And then cosine over sine is cotangent. So the derivative of cosecant that you want to get memorized is a negative cosecant x times the cotangent of x. That's what we need to get memorized. So we really just want to be able to go from here to here and just get that down. Usually at this point, I have people try these in class, see if you can get through them. So if you wanted to pause me and give this one a shot, go ahead. I'll continue on, and if you just want to follow, that's okay too. So the derivative of secant is the same as the derivative of 1 over cosine. And we're using sine and cosine because we know what those are from the front page. This is another quotient rule, just like the one above it. We're going to do the derivative of our denominator. I'm sorry, I keep saying that. We're going to leave our denominator alone, so cosine of x. And then it's the derivative of our numerator, which is a 0. Quotient rule, we subtract. Leave your numerator alone. Take the derivative of your denominator. That's the cosine's derivative, and the derivative of cosine is negative sine of x. All over your denominator squared. What that then leaves us as this cancels should be a positive sine of x over cosine of x quantity squared. Similar to the previous question above this, we're going to split this up. Sorry, let me erase that. Hold on, I'm fumbling around here. So we should have 1 over one of those cosines, and then the sine over the other cosine. So that, like I showed in the previous problem, if I multiplied those together, I would get this. I would get a simple sine of x on top, and I would get cosine of x squared in our denominator. This is just written differently so that we can now see 1 over cosine is a secant of x. Sine over cosine is a tangent of x. So moving forward, if I ever ask you for the derivative of secant, we want to jump right to that. The derivative of secant is secant x tangent of x. Okay. Last one, derivative of cotangent is the same as, we're going to use sines and cosines again. Cotangent is a cosine of x divided by a sine of x. and then we do the quotient rule with that. So if you want to see if you can get through one, pause me, go through all this. I typically do kind of wait and see if we can come up with this on our own. And then whatever we get is the derivative of cotangent. All right, I'm going to move on and then see if you got it right. If you did, pause me. If not, just follow along. It's our denominator unchanged. The derivative of the numerator, which is a negative sign, minus the numerator. And then the derivative of our denominator is the derivative of sine, which is cosine. All divided by your denominator squared. Simplify this. When we multiply these two guys together, that's a negative sine squared of x. When we multiply these guys together, we get a negative cosine squared x. And then that all gets divided by a sine squared of x. I'm going to simplify this to be, I'm going to pull out a negative 1. No chance I fit that in there, so let me do that below. Got a little excited and wrote too big, so I'm going to do a negative 1. Factor that out, so I create this sine squared x plus cosine squared x that we should be familiar with, over a sine squared of x. So what this should give us is the negative 1 that I factored out, and then we know sine squared plus cosine squared, so within this parentheses, sine squared of x plus a cosine squared of x is a 1. And then all over the sine squared. So what we really end up with is a negative 1 over sine squared, which, I'm really struggling to keep this in bounds here, is 1 over sine is a cosecant. So 1 over sine squared is cosecant squared. So that the derivative of cotangent is there. All right. Those are your 6 trig derivatives. So usually on the test, I ask you to prove one of these, 1 or 2. Before the test, we just need to get these memorized. So you can see not a ton of problems here. We'll just work our way through these. These are actually really quick. All I want you to do is find your derivative. So some of these are old rules. So the derivative of x, we would have already known as a 1. And we now know the derivative of sine of x is a cosine of x. And that's it. Second one, I would rewrite this real quick. And then take our derivative. So it's going to be a negative 1, x to a negative 2, just using our power rule. And then now I want to talk about this in a little more detail. So I'm going to, let's say over here, and I'll erase it in a second. What we really have here, if I want the derivative of 5 sine of x, I'm just going to do it over here. This is technically a product. It's 5 times sine of x. So that would imply that we would want to do the product rule. So when we do the product rule, we would do the derivative of the first and then leave the second one alone, plus the first one unchanged, and then the derivative of the second term would give us cosine. What you would then notice is this is going to cancel, and all we really end up with is this 5 cosine of x. So what we want to recognize to make our work easier and not do the product rule when it's just more work than what needs to be done, if we have a product and the first term is really just a constant, all we really need to do, we don't want to have to do a product rule in here. What that really just shows is we can just drop this constant down. So basically leave that alone and just take the derivative of the second term. So this 5 we can just drop down, and then the derivative of sine of x is cosine of x, and we would get the same thing we would get by doing the product rule with a lot less work. All right. So negative 1 over x squared, and then 5 cosine of x. That's our final answer. Now, that is very much different than this next question. If all I had here was like a 6 times cotangent of x, then I would just drop that first term down and then take the derivative of the cotangent. That is not what we have going on here. So what does tend to start happening, and you really want to stay on top of the assignments and the notes with this, as all these rules get thrown together, this can get rather challenging. This is an x squared times a cotangent. This is a product rule. So it is still any old rule that pops up as we move along. We need to now recognize that when we start dealing with our new things, which in this case is the derivatives of trig functions. So this is a product. So we would have to take the derivative of this first term, which is 2x, and then leave the second term unchanged. Then with the product rule, you would add, leave the first term alone. And the derivative of the second term is a negative cosecant squared of x. That was the derivative of cotangent. Sometimes people have a hard time simplifying these. These tend to get a little messy. The first thing, there's not a whole lot we can do, just 2x cotangent of x. But then when we go ahead and simplify this, that would just look like a negative x squared cosecant squared of x. All right. Four and five, we'll really just do one. I'll spare you some time here. Just understanding it's a quotient rule, but we now need to apply any derivative that we come across that's a trig function. So it's our quotient rule. The denominator unchanged. Take the derivative of the top, so that's a negative sign. We subtract in the quotient rule. Leave your numerator alone. And then the derivative of our denominator would just be a 1. Square your denominator. In the numerator, as we simplify, we get a negative x sine of x minus cosine of x, and then all over x squared. That's our answer. Like I said, 5 we'll skip. We've done about 4 quotient rules today, so we don't necessarily need to crank out another one of those. Just know the quotient rule, know when we get to the derivative of cosine, it's a negative sign. 6, super short and sweet. The derivative of 2x is a 2, and then just the derivative of cotangent is a negative cosecant squared of x. So pretty simple. 7, we do want to make things easy on ourselves. So you could take the derivative of this right now with a quotient rule, but that would be a little more work than we want to do. We would want to just recognize that 1 over tangent is the same as a cotangent, and then we'll be able to take our derivative pretty quickly. So the derivative of 5 is a 0. That's going to go away. All we really end up with is the derivative of cotangent, which we just did in the previous question. It's a negative cosecant squared. All right, finally number 8. This one I usually, sometimes we get to 9, sometimes we don't, but I usually, as we're concluding class here, try to have people do this one on their own. So I would, in this case, suggest pausing me, see if you can do this. There's a little more here than meets the eye, and I'd like to see if we're understanding that to do it. Now, if you don't, just follow along, but it is one that, typically I like to see if we're following and try this. So, first derivative. Just memorizing from at the top of the page what the derivative of cosecant was. And we would get a negative cosecant of x times cotangent of x. Most people get that. It's pretty simple. Then we go to the second derivative, and this is now, again, putting all these things together can be a little tricky in terms of keeping all of your rules straight. So if you did this and you recognize this, that's good. And if not, not a big deal. It's the reason I have you try this first initially, just so you can kind of see some of the things that you want to now be careful of. What we have here, when we go to take this derivative, is a product. We are multiplying 2 different functions together. This negative cosecant of x is getting multiplied by a cotangent of x, so our product rule is necessary for us to take the second derivative. And if you recognize that, that's really good. And if you didn't, you will eventually. So as we go through this now, we want the derivative of the first term. So if you understood the derivative of cosecant was a negative cosecant cotangent, then a negative cosecant should give us a derivative of positive cosecant x, cotangent of x. That's the derivative of the first, but the second term then should just get rewritten and be unchanged. Product rule, we add, we then leave the first term alone, so that negative cosecant of x doesn't get changed. We then take the derivative of the second term. So now we're taking the derivative of this cotangent. We've done that 3 times in a row now. That one is negative cosecant squared of x. Our simplified version then, notice this plus sign. Sometimes people, again, have a hard time simplifying all this. So we can combine these guys. And all that would give us is a cosecant of x times a cotangent squared of x. And then after the plus sign means we can simplify all these together. So we have a negative and a negative is going to turn this to positive overall, so still positive. And then that should give you a cosecant cubed of x. That then is our answer. Okay, last one, sine of x. So rough draft of what the sine of x curve looks like. What I'm giving you is finding the equation of a line that is normal. So all normal means, basically, is perpendicular. Since a curve is constantly changing, it has different slopes everywhere. We don't necessarily say a line is perpendicular to a curve because we don't necessarily get right angles throughout, at that point. But what normal means is perpendicular. It means it's perpendicular to your tangent line. So if I draw on a tangent line at 0, 0, we've written the equation of tangent lines plenty in notes and then on your quiz the other day. What we're now going to do is write the equation of the line that's perpendicular to that line. Okay? So I've mentioned a few times, even as these get harder, just keep in mind, if we're ever asked to write the equation of a line, which is what I'm asking you to do right now, that always pretty much boils down to the two things that you always have known you need to use to write the equation of a line, which is a point and a slope. The point is easy because I give it to you. So instead of x comma y, we actually know what our point is. It's 0, 0. What we now need is the slope to go with that point. So hopefully at this point we know the slope is our derivative. The function we're taking the derivative of is sine of x there. The derivative of sine of x is cosine of x. We want to evaluate it at this x coordinate here of 0. So the cosine of 0 is 1. So here's just where you need to be careful. This is the slope of the tangent line. So if that was the question, that's the slope that we would use right here. We would go ahead and put that positive 1 right there because that's the slope of our tangent line. This is really messy. What we are wanting, however, is the slope of our line normal or perpendicular to the tangent line. So what we're really looking for is our perpendicular slope. Not that our slopes can necessarily be perpendicular, but what is the slope of our perpendicular line? So that's the opposite reciprocal of 1, which is really still 1 over 1, but it would change our sign to be a negative 1. We now have our point, we have our slope, we can write our equation, and then that's our answer. All right. So hopefully that's making some sense. You really just need to get these memorized. We use them all year. Even jumping in tomorrow, there's one more big rule tomorrow. Sines, cosines, tangents, all these trig functions are going to pop up, and you want to be familiar with them when we do them in class so you're not completely confused on where all this is coming from. Okay. So with that, I will see you Monday. Hopefully this went reasonably well. If not, reach out to me sometime on Monday somehow, and I can do some more explaining if you're lost. All right, with that, have a good day, and we'll see you guys Monday.